In this final video for this section, we are going to be talking about multiples. Now, when I think of multiples, I just think of taking a number and counting by that number. We want to talk about multiples of 2. We count by twos. 2, 4, 6, 8, 10, 12. Those are all multiples of 2. And every number has an infinite number of multiples. They just keep going forever. So if we wanted to say look at the first few multiples of 5, it would look like this. So here would be our first few multiples of 5, 5, 10, 15, 20, etc. So take a moment and practice, just write out the first 15 multiples of 7. So do the same thing that you see on the screen, but do it with the number 7. So when we pair these together, what we're going to see is a list that looks similar. I'm not sure why it stuck it way over there. Not sure why there's a 5 down there. Oh, that's why. Let's see if I can fix this. Let's just shrink that font text font. There we go. Okay. So we've got multiples of 5 and multiples of 7, right? So here's 5 and here's 7. And just take a moment to notice things. What do you notice about those two lists? One thing you might notice is that there are some numbers that show up in both lists. So let's find them all. Let's find all the numbers that show up in both lists. Well, I see 35 here and 35 there. I also see 70 here and 70 there. Well, there's a couple multiples that they have in common, but as I said a minute ago, every number has an infinite number of multiples. So if we continued these lists, we would find more numbers that they have in common. We would eventually find more and more numbers that they shared. And so when you're comparing two numbers and you're looking at their multiples, there's actually an infinite number of those as well. Here is a visual that accompanies this concept. So what you'll see here is, again, kind of like when we were looking at factors, or we actually saw something like this earlier in one of the first videos in this section. Here's the number 0. And then if we're counting by 5s, here's these red arrows. If we're counting by 7, it's these blue arrows, and they land right there together, right? This was like that question that kicked things off with the clock, right? The 8-second clock and the 12-second, the timers blinking on the flashing with the population clock, where they both land on that 35 at the same time. And so we say that a number is called a common multiple if of two numbers if it is a multiple of both of them, right? That's what we could define, how we define a common multiple. And so between the numbers 5 and 7, 35 is a common multiple, and so is 70. And we could, again, keep going with those. But among that group of common multiples, and I'll even write some of the next ones, we had 35 and 70. If you just kept going, the next one we would get to would be 105, and then 140, and then 175. And again, it would keep going. When you start looking at common multiples, there's always going to be a smallest one. There's not going to be a biggest one because they go on infinitely, but there's always going to be a smallest multiple that they have in common. And we have a name for that, and it is called the least common multiple. Least common multiple. Often we will abbreviate that as LCM. So the least common multiple between 5 and 7 is 35. And of course, we have a way to write that and a formal definition that I will share with you. So for any two non-zero whole numbers, A and B, again, 5 and 7, the least common multiple written LCM parentheses 5 comma 7 is the smallest multiple of both A and B. And in this case, that would be 35. So let's take a quick look at some Common Core content standards related to the things that we are learning. And so what are students actually needing to know? So this is grade 6. Students need to find the greatest common factor of two whole numbers less than or equal to 100 and the least common multiple of two whole numbers less than or equal to 12. So they need to be able to do what we just did with 5 and 7 for all numbers up to 12. And then also greatest common factors, like we talked about in the previous video, they need to be able to do those with all numbers less than 100. So there are different ways to model this, visuals that help us see this a little bit. We already looked at if I scroll back up, we looked at sort of this number line, right, where we jump count, right? That's one way we can see that. But there's another way that we can see this as well, and it's using rods. So what we'll do here is we're going to examine the least common multiple of 4 and 5. We're going to find the least common multiple of 4 and 5. And here is a model using rods. So one of the things that you'll notice as you examine this picture is that we just start by putting one 4-unit rod down and one 5-unit rod down. But what we notice is that they don't line up here, right? They don't measure the same distance. So we just keep lining them up one after the other. Here's another 4, and here's another 5. And again, they don't line up. So we put another 4, and we put another 5. They still don't line up. So we put another 4, and we put another 5, and we actually put one more 4, and what do we notice? Now those rods are the exact same distance. It takes 5 4s and 4 5s, but eventually they have the same exact distance, right? The number 20 then is the smallest length that can be formed by rods of both sizes. So we say the least common multiple of 4 and 5 is 20. So that's a really good visual representation of that. So here's another one. If we look at the numbers 3 and 10. So if we want to find the least common multiple of 3 and 10, we could sketch a diagram that looks something like this. And again, what you'll notice are these short rods of length 3. So 3, 3, 3, 3, 3. And then we have a length of 10. And here's the end of 10, but that does not line up with a length of 3. 10 is not divisible by 3. So we put more 3s, we put another 10, and again, we don't have anything lining up here. So we put more 3s, we put another 10, and finally, there we go, right? So this entire length then is 30. So we say the least common multiple of 3 and 10 is equal to 30. So the rods is one method that we can use with a visual, right? You can use manipulatives of some sort to do that and represent that. Another way we can do it, if we're looking at ways to find a least common multiple, did. A second way that we could do it is just make a list of the numbers. So we list out numbers. That's what we did earlier with the numbers 5 and 7. It was the way we started this video. List out the numbers, the multiples of 5, list out the multiples of 7, and just find the first one that they have in common. Now, that method works fairly well with small numbers, especially if you only have 2. But as soon as you introduce a third number that you're trying to find the least common multiple of, or you work with really big numbers, these two methods are not going to be very efficient. And so you can probably guess that a third way we're going to do this is to use prime factorizations. Prime factorizations. I told you this was going to be a really useful tool for us for this whole section. So we're going to use prime factorizations. And what are we going to do with those? Here is how prime factorizations work. The least common multiple of 2 or more numbers can be built from their prime factors by using each prime factor the maximum number of times it occurs in each of the numbers. So again, that might be one that you want to read through a couple times to make sense of, and then I'll explain how this is going to work. First, I'm just going to lay it out with and examine some factor trees, and then we'll sort of look how we can organize our information well. So let's try to find the LCM, the least common multiple, of 40 and 66. Okay, so we're going to find the least common multiple. Again, if we counted by 40 and counted by 66, what would be the first number that we would come to? So let's start with factor trees. And again, if you want more practice with that, pause the video and try to do your factor trees. So 40 would be maybe 5 times 8. 8 is 4 times 2, and 4 is 2 times 2. 2 times 2. There we go. So here would be our prime numbers. And then if we do for 66, 66 could be 6 times 11, and then 6 is 2 times 3. So we just look at the numbers that I have circled there. Those are only prime numbers. And then if we go back to the definition or the description here, we build the least common multiple from these prime factors by using each prime factor the maximum number of times it occurs in each of the numbers. So what I always like to do here is I just look at all of the numbers that we have at the bottoms of these branches, all of those circle numbers. And I notice we have 2s, we have 5s, we have 3s, and we have 11s. So just scan all the circle numbers. I have to use those numbers to build this least common multiple. But I need to know how many of each one of these numbers do I have to use. So I look within the number 40. So I'm just going to focus on this one to start. How many 2s were used there? 3. Okay. How many 2s were used in 66? Just 1. We're going to always go with the maximum, whatever the bigger number was. So in our least common multiple, we're going to start with 3, 2. I said the number 3, but I wrote that I wanted a 2. There we go. 3 2s, because it's the maximum number in any individual number that we're working with. Well, we're done with the 2s. Just to keep things in numerical order, I'm going to do the 3s next. So we've got a 3 in the 66. We don't have any in the 40. So the maximum number of times it occurs is just this one time. So we need to include a single 3. We're done with our 3s. Then I go to 5s. Well, again, just like 3s, there's a single 5. So that's the most that it occurs. And there's a single 11. So we need to include an 11 just once. When we multiply all of those numbers together, we get a pretty big number, 1,320. That is going to be the least common multiple of 40 and 66. So it's looking at the prime factorizations, looking at all the different prime factors, and then choosing the most number of times that each individual factor occurs in either of those numbers. I think this is kind of confusing to look at. I like to organize my information a little bit better. But just to note something of importance, when it comes to this concept that we're working with, why is it important? As you see here in fifth grade, this is a content standard, not fifth grade, sorry, it's the standard number 5. It says students in general, right, have to explore prime and composite numbers and discover concepts related to the addition and subtraction of fractions. Oh, there's fractions. We're going to be talking about that in our next module. Fractions as they use factors and multiples, including applications of common factors and common multiples. The concepts we're learning in this section, greatest common factors and least common multiples, are crucial to the ability to work with fractions. And you have to work with fractions all the way through mathematics, right? In all levels of mathematics. In algebra, advanced algebra, they just keep on showing up in many different ways. What we're doing here is we're laying a really strong foundation for that work. Okay, so let's get back to an example here. We're going to find the least common multiple of 198 and 210. And so what I want you to do is start by doing your factor trees. Okay, so start by doing your factor trees. I'm not going to show all the factor trees because we've done a lot of them. But what you should end up finding is that 198 is equal to 2 times 3 times 3 times 11. And 210 is equal to 2 times 3 times 5 times 7. Now, if you recall, when we were working with greatest common factors, we sort of stacked them and kept them lined up, and it helped us organize our information a little bit better, right? In fact, just to show you what that looked like as a reminder from the previous video, if we were trying to find the GCF of these numbers, we would do something that looked like this. This should look familiar to you, right? Remember how we kept our 2s in line, our 3s in an area, our 5s, our 7s, our 11s. We do the same thing when we're going to do this least common multiple. But there's going to be a really important difference. When we did greatest common factors, we only kept the numbers that showed up in both numbers, right? The factors, factor of 2, the prime factor of 2 showed up in both lists, and the same with 3. When we do this with least common multiples, it's going to look like this. Just want you to take a look at that, examine it, explore it, and notice things first. We start them the same way, don't we? Notice how it's set up exactly the same way. Again, I'm just going to draw some dotted lines here. Here's our 2 section. Here's our section of 3s. Here are our 5s, 7s, and 11s. But when we're finding the least common multiple, we just drop them all down. We have 2s, we have 3s, we have another 3, we have 5s, 7s, and 11s. And so it's a collection of all of these numbers that gets multiplied, not just the ones they have in common. So when we do multiply all those numbers together, what do we get? We get 6,930. So 6,930 is our least common multiple of 198 and 210. So let's try another one. Let's have you try one of these. So, or maybe I'll talk you through this next one. Let's find the LCM of 28 and 44. So again, I'm not going to do all the factor tree work. If you want to practice, go for it. But what we find is that 28 has a prime factorization of 2 times 2 times 7. 44 has a prime factorization of 2 times 2. And I'm going to write that 11 over there, right? So we're going back to that idea of lining up those common prime factors, just like I showed here, right? And so when we drop every single one of those factors down, we get 2, 2, 7, and 11. 2 times 2 times 7 times 11 is 308. And that is that least common multiple of 28 and 44. Again, if you're counting by 28, counting by 44, that's going to be the first number that you get to in both lists. Now, bonus question, what's the greatest common factor of these two numbers? Going back to the previous video, you can look up here in this same grouping and find that, because it's going to be the numbers that they both had in common, a pair of 2's. 2 times 2 is 4. So I think even showing it in this relationship can help sometimes. 4 is the biggest number that fits into both 28 and 44. And 28 and 44 both fit into 308, and that's the smallest number that they both go into. That's how I always kind of make sense of it in my own head. All right, let's look at another one. So maybe you tried this one on your own. So this is finding the LCM of 21 and 40. Why don't you give this one a shot on your own and then unpause that video when you come back. So when you line these up, it's going to look something like this. 41 has a set of 3 2's, so I'm going to start there. 21 has a 3. 40 has a 5. And 21 has a 7. So it's going to look like that. Did you notice anything interesting or different about this one? I'll keep going and I'll come back to that. So when we drop them all down, what we end up with is multiplying all of these numbers together. 2, 2, 2, 3, 5, and 7 for a total of 804. 804 is that least common multiple of 21 and 40. You know I'm going to ask you that same bonus question, though, right? What's the greatest common factor of 21 and 40? Maybe this is the thing that you thought might be a little interesting from a moment ago. Do you notice that there are no numbers, no prime factors that both 21 and 40 share? So what's the greatest common factor if they share nothing? 1. Do we remember that? And do you remember the term we used to describe a pair of numbers whose greatest common factor is 1? They are called relatively prime. They are relatively prime. We learned that in a previous video. So before I have you do one more, I want to talk about a relationship between GCFs and LCMs. And it has to do with how you can find one. So I am going to go back to this one right here that we did just moments ago, 28 and 44. And I'm just going to I'm going to take a little snap of this and paste it, and we're going to examine it in a little more. So this is what I had drawn in my own handwriting earlier, but now it's obviously much neater. We found moments ago that the least common multiple of 28 and 40 is 308. And then I also asked you the bonus question, and I said, what is the GCF? of 28 and 44. And if you recall, we said that was 4 because it was those two numbers right there. And so there's a really nice, interesting property that looks like this. If you are trying to find the least common multiple of any two numbers, we'll say 28, 28 and 44. One way you can do it is take the two numbers, 28 times 44, and multiply them together, but then divide them by whatever the greatest common factor of them is. And what I want to do is show you why that works. And so before I do that, let's just figure out what that would be. So let's calculate 28 times 44, 1,232. So that is equal to 1,232 divided by the greatest common factor we found was 4. And when we divide 1,232 by 4, we get 308. So you might be wondering, why is that? Well, if we do a little expansion, we can see why that is. So if you look at what I have here, least common multiple is what we're trying to find. And if you just look at this big fraction here, this is these three numbers, 2, 2, and 7. And these three numbers, 2, 2, and 11, multiplied together, which is essentially 28 times 44. It's this thing times this thing. And then in the denominator, we have the greatest common factor, the things they had in common. 2 times 2. Later, we're going to be learning about multiplying with fractions, but one of the things that you're going to see is that when you're dividing fractions, when you have a fraction and there's multiplication on top and bottom, you can remove common factors through a cancellation technique. So one of these 2's on top would cancel out with one of the 2's on the bottom because they would have a value of 1, 2 divided by 2. Same thing with these. When we do that, when we cancel those, what we end up with are these numbers. Those numbers look familiar. 7, 2, 2, and 11. They're these, right? They're the ones that we ended up multiplying to find that least common multiple. And so that's what we would do here, okay? When we're dividing by 4, this 1,232, it's the same thing as removing those 2's right there. Why does that work? We're essentially multiplying all of these numbers together, and then we're removing ones they had in common. This is actually the same thing as this process, right? So there's this interesting, unique relationship and a formula that's even associated. Some people enjoy formulas, but we can state that this as a theorem for least common multiples of two numbers. For positive integers a and b, the least common multiple of a and b is equal to a times b over the GCF of a and b. That's what we showed right here. And then when the GCF of the two numbers is 1, it's just going to be a times b. Why? Because you would just end up dividing by 1. So if you pick any two numbers, such as, let me go back here. Remember when we found the least common multiple of 21 and 40? That theorem that we just stated says you can find that if we know that they have a greatest common factor of 1. If we know 21 and 40 have no factors in common, all we end up needing to do to find the least common multiple is just do 21 times 40. And it's going to give you 804. So that is a unique, it's sort of like a next level understanding of these ideas. So why don't I have you try one more before we wrap this up. See if you can find the least common multiple of three numbers: 14, 34, and 60. 14, 34, and 60. You may recognize these numbers. We found their GCF earlier. So we're going to take 14, 34, and 60. And when we list out their prime factorizations, it's going to look something like this. Fourteen is equal to 2 times 7, 34 is equal to 2 times 17, and 60 is equal to 2 times 2 times 3 times 5. We line them up, we drop them down. 2 times 2 times 3 times 5 times 7 times 17. Multiply all those numbers together, and we get 2 times 2 times 3 times 5 times 7 times 17, 7,140. 7140. And that is our lesson on least common multiples. And so hopefully you've got a better grasp on these things. These are concepts that we learn, but sometimes we don't always understand how they work, why they work the way they do, and keep playing around with these, keep exploring these, because they're really going to help lay a good foundation for your understanding of just numbers in general.